Boxes to plans. Growmore Girl, Ysleta, YWLA.
Hello, we are the Growmore Girls. My name is Winnell Maxwell. I'm the research manager. I did the research, project documentation, monitoring of expenses, receipts, donations, slideshows, and portfolio completion.
Hi, I'm Alexa Portillo. I am project coordinator. I set up meeting times, project documentations, and portfolio revisions.
I'm Valerie Khanwa, and I am the project manager, the creative design lead. I helped plan and execute the project, and I facilitated the 3D printing process, and I pitched in on the portfolio design.
The first project that we did together was Weathering Fest, which was an event hosted by our local news channel. We presented a project on air pollution and acid rain. We won first place district and first place overall, and we decided to take on another challenge as a team.
In the beginning, we struggled to find a project we wanted to do, and we were trying to look for problems in El Paso, but we decided to go into a small area, which was our school, and we saw this room full of cardboard boxes, and we decided to use those cardboard boxes and put them back into our plants and back into the earth, and to help grow plants.
The purpose of boxes to plants is to get rid of cardboard waste and food waste in our schools and homes. Our goal was to take this waste and turn it into something that can be put back into our school campus and to ensure that we stay eco-friendly the entire time while making sure that our waste doesn't end up in any form of a landfill.
The method that we decided to use for our project was a scientific method because we were all used to and comfortable with it. We have our observation. Our question targeted the issue of cardboard and food waste. We have our hypothesis, experiment conclusion, and result analysis.
For our variables, we had our constant variables, which were the cardboard and all our additives. And we made sure that each cardboard and additives were put to a same amount and to scale. And for our independent variables, they were the coffee, the banana peels, and the eggshells. For those, we made sure they were each also to scale and each the same weight. And for our dependent variables, they were the length of the germination of the seeds and the amount of seeds germinated. We had a control group for the fact that we needed something to compare all the rest of our petri dishes to, and we figured that if we test the control group compared to the others, we'd know whether the cardboard is better on its own or with the additives.
And then we had 3 nutrient additives, coffee grounds, banana peels, and eggshells. The coffee grounds were a good additive because of the nitrogen, which can be used to help the plants grow. And then we added banana peels because of the multiple different minerals in the banana peels, like potassium, phosphorus, and calcium, which are big help with plants and are really essential to growth. And then we had eggshells, which have calcium as well, that help with soil.
Our hypothesis, we predicted that the banana peel was going to have the highest germination rate due to more beneficial minerals.
For our materials list, we had a hot plate, blender, mung beans, petri dishes, and so on. But our main materials were the coffee grounds, eggshells, water, cardboard, and our petri dishes.
Our expenses and receipts, we made sure to keep track of the cost and we didn't go out of budget.
And then we had our donations. All our donations came from YWLA staff and students. We are so greatly appreciative of the donations that we received. They were a big help and we couldn't have done them without done our project without them.
We also received a donation from the YWPN Society, and they really helped us pay for all our finances. So, for our procedure, we had cardboard and removed all the tape on the cardboard. This was to prevent any chemicals from seeping into our seeds and seeping into the ground, especially. And with the cardboard, we put it in warm water, and the warm water really helped with the ripping process. And with that ripped cardboard, we put it into the blender and put warm water, water of 120 Fahrenheit and 200 grams into the blender, and we made pulp out of that. And with the pulp, we put it into our petri dishes and added seeds. And we let these seeds grow over 3 days.
Our control group data, our average mung bean germination was 3.75 out of 4 mung beans. Our average germination rate percentage was 94%, and our average sprout length was 1.8 centimeters.
For the data, on the left, we have the line graph, which was a percentage of seeds germinated. And on the right, we have the bar graph, which was the length of the seeds germinated.
And then we had our experimental group data for our banana peels. The average mung bean germination was 3.25 out of 4 mung beans. The average germination rate in percentages was 81.3%, and the average sprout length was 2.15 centimeters.
Experiment group data for banana peels. The line graph shows the germination rate percentage, and then the bar graph shows the longest sprout length in centimeters.
For our coffee grounds, our experimental group, the average mung bean germination was 2.25 out of 4 mung beans. The average germination rate percentage was 56.3%, and the average sprout length was 1.3 centimeters.
The experimental group data for coffee grounds, on the line graph, it shows the germination rate percentage. And then on the right, we have the bar graph that shows the longest sprout length in centimeters.
And then we had our group data for eggshells. The average mung bean germination was 2.25 out of 4 mung beans. The average germination rate percentage was 56.3%. The average sprout length was 1.12 centimeters.
This is the experimental group for eggshells. And again, on the left, we have the percentage of seeds that germinated. And on the right, we have the length of the seeds that germinated.
And then we have our results. The control group had an average germination rate of 94% and an average of 1.8 centimeters in sprout length. The experimental group with banana peels added had an average germination rate of 81.3% and an average of 2.15 centimeters in sprout length. The experimental group with coffee grounds had an average germination rate of 56.3 and an average of 1.3 centimeters in sprout length. The experimental group with added eggshells had an average germination of 56.3% and an average of 1.12 centimeters in sprout length. In conclusion, our hypothesis was somewhat correct. The control group with nutrients had a better percentage in germination rate, but banana had a better length rate. This shows that even though the control group had some good things, the banana still had a better length. And we realized that the coffee didn't work because of the nitrogen. It didn't have nitrification because it wasn't in compost. For it to work, it had to be with compost. And then for the eggshells, we believed it didn't work because we weren't able to grind it into a fine powder, which is needed for the calcium to soak up, for the beans to soak up the calcium. And also we found that the eggshells seem to absorb the water in the petri dish, kind of making it dry, harder for the beans to germinate.
For in future research, we plan to make the cardboard into molds and put them as plant plant planters. And we got these molds from Miss Madrid, one of our donators, our librarian, and we used the 3D printing to place the cardboard in and to test the different shapes of cardboard that will promote the growth of the seeds. We also plan on using banana and control, because the control worked the best and with the growth of the seeds. However, in the long run, when the seeds start to actually create leaves, the nutrients, the banana peels, when they're fully decomposed, will help the plants grow and uh, and protect them from all the environment.
The experts we spoke to were Eduardo Rascon, a Texas A&M AgriLife Extension agent, Abby Johnson, Research Associate, Texas A&M Agriculture Research, and Barbara Aguilar, Master Gardener. Two of them were Texas A&M AgriLife Extensions, and most of them were Texas Master Gardeners.
And this is our communication log. We first talked to Ms. Aguilar on March 2nd. We asked her how the potassium would affect non-flowering plants like the mung beans we were using. Ms. Aguilar explained that the potassium would help with roots rather than helping with flowering. We then talked to Mr. Rascon on March 6th about why there would be stunted growth or germination in the experimental group with coffee grounds. He then explained that the coffee grounds have such high levels of nitrogen that it wouldn't help the growth. And then we talked to Ms. Johnson last, and she explained that potassium plays a huge role in the growth of plants with photosynthesis and transpiration, which is how water enters and exits a plant. She also spoke about how without potassium, plants would most likely wilt and die, and it makes it absolutely necessary that all of our plants have potassium.
For our thank you letters, we had Ms. Aguilar and Ms. Madrid, who was our librarian, and she donated the filament for the 3D printing. And Ms. Drews, who was our project coordinator, she really helped us through this process and getting it all together. Mr. Rascon and Ms. Golston.
And then we have our bibliography. And we would like to say thank you for listening to our presentation and taking our project into consideration. We really appreciate it and hope you have a nice day. Thank you.
Thank you.